So in these notes, we're going to cover two sections. Sections of things that we've done before. We're going to throw in a different form of an equation and see how things turn out. We're going to work at slopes and rates of change and solving equations. First of all, we need to remember that a slope is a non-vertical line passing through the points x1, y1, and x2, y2. These are generic points. That's like if I said 3, 4, and 5, 37. So this would be my x1, this would be my y1, this would be my x2, and this would be my y2. From that, I get what we call the definition of slope. Slope, we use the letter m, and we can say this is delta y over delta x. And we can say that the delta is the word change. So we say this is the change in y over the change in x. The change in it tells us that I want to take a difference. I want to subtract. So I want to subtract my x's and subtract my y's. Technically speaking, it doesn't matter which y or x goes first as long as my first y comes from the same coordinate as my first x. I can do y2 minus y1 over x2 minus x1, or I can do y1 minus y2 over x1 minus x2. The order of the x's and y's don't matter as long as they match vertically. And this is always, when we look at a graph, is what we call rise over run. We've been doing this for a while, so let's use this to do a couple problems. So I'm going to pause to grab a sheet of paper. So let's go ahead and do example 1. I want to find the slope of the line passing through negative 3, 5, and 2, 1. Again, I have the slope equation. I don't have to do both of these equations. All of these are finding the same thing, the difference of the y's over the difference of the x's, the change in y over the change in the x. And I put that just as a reference to help myself. So I need to take my y's, and I like to start with the second one and go 1 minus 5 over 2 minus a negative 3. And I start by writing what it is. It's not a, it is a negative 3, so 2 minus a negative 3. 1 minus 5 is negative 4. 2 minus a negative 3, well, that's 2 plus 3. So this is negative 4 over 5. And that's my slope. I have a rise of negative 4 and a run of 5. At this point, I want you to try example 2. Do the same thing. Pick my y1, my y2, my x1, my x2. Find the difference of the y's, the difference of the x's, and see what you come up with. Go ahead, and the slope that I came up with for example 2 is negative 2. Pause right now and try that problem. Okay, now that you've tried these two examples and you've seen how they work, let's talk about what slope can tell me. So when I look at this, I want to classify lines by their slopes. This is something nice to know. So if I look, and my slope from left to right is rising. As I go left to right, my slope is rising. This is a positive slope, and my slope is greater than 0. That means the same thing. From left to right, if my slope is declining, going down from left to right, that means I have a negative slope, and my slope is less than 0. So here my slope could have been a number like 5. Here my slope would have to be a number like negative 2. Positive slopes, negative slopes. Horizontal line. A horizontal line is a line that doesn't rise or decline from left to right. My x's actually cancel out. I get 0 over a number. 0 divided by any number is always 0. So my slope of a horizontal line is 0, and it's always going to be horizontal. It's like the equation y equals 4. This is this horizontal line where my y-intercept is 4. Conversely, the opposite, or you can say the reciprocal, or you can say the perpendicular of a horizontal line, is a vertical line. An equation is like x equals negative 3. This is where I get a number divided by 0. And I need to remember I cannot divide by 0. So this isn't 0. This is no solution. This is no slope. We say this is an undefined slope. But this is not 0. 0 is not the right answer. There's no slope or undefined slope. This is my answer, and it's always going to be a vertical line if that's the slope that I come up with. Let's see what this can do for me. Let's run this little test over here. So here we go. I have 4 choices down at the bottom, A, B, C, and D. Using that last slide, you can scroll back, rewind, and copy down that if you haven't copied it. So let's classify the classification lines by slope. Without graphing, tell whether the line through the given point rises, falls, or is horizontal, or is vertical. Well, let's see, a line with a blank slope rises from left to right. So from left to right, if it rises, well, that means I have to have a positive slope. And that means if it's positive, my slope has to be greater than 0. And so which of these down here, A, B, C, or D, rises from left to right? Well, that's D. So the answer for this is D. The next one, a line with a blank slope falls from left to right. So if it's falling from left to right, it's going to be doing this type of thing. Well, that has to be a negative slope. That means that my slope M is less than 0. Which of these, A, B, C, are falling from left to right? That has to be A. A line with a line with a slope of blank is horizontal. So again, I'm now looking at the difference between vertical lines and horizontal lines. Horizontal lines, remember, had 0 slope. So the slope is equal to 0, and that's a horizontal line, so that's C. A line with a blank slope is vertical. That's an undefined slope because I cannot divide by 0. M is undefined because I was trying to divide by 0 and I can't. And that has to be process of elimination, letter B. So have that and make sure that makes sense to you. Let's see what else I can do. So, as I flip through my notes, without graphing, tell whether the lines through the given points rise, fall, horizontal, or vertical. Let's try this. So my first one, I want to find the slope. -6 minus a -4 divided by 1 minus 3. Well, this is -6 plus 4 over 1 minus 3 is -2. -6 plus 4 is -2 divided by a -2 is going to be a positive 1. Positive 1, that slope, my M is greater than 0, so this is going to rise. I can't spell rise. This is going to rise from left to right. Letter B, I want you to see if you can figure this out and see if you agree. I will have the answer to letter B in class, and we can check it then. Let's go on to a different topic and see if it works. I'll tell you what, letter B, I'm going to tell you that I got this to be a vertical line. See if you can figure out why. Pause now and work on letter B. Slopes of parallel and perpendicular lines. Consider 2 different non-vertical lines, L1 and L2, with a slope of M1 and M2. Parallel lines. The lines are parallel if and only if they have the blank slope. Well, here are parallel lines. Remember, the most basic way I can talk about slope is rise over run. Rise over run. If they're parallel, the rise is going to be the same, the run is going to be the same. So they have to have the same slope. Slope of the first line, slope of the second line have to be equal. Perpendicular lines. The lines are perpendicular if and only if their slopes are blank of each other. So this is what perpendicular lines look like. Perpendicular means they have that 90-degree angle right there. And the slope of a perpendicular line is the negative reciprocal of the other line. So if M1 is going to be the negative reciprocal of m2. So negative, and I switch the fraction. If I multiply my two slopes, I'm going to get negative 1. And this is something you should have seen in geometry if you didn't already see it in Algebra 1. Let's double check. Here's a little note sheet you can copy down. Parallel lines have equal slopes. M1 and M2 are the same, so I would have a slope like 3/4 and 6/8. Same slope. If I reduce 6/8, I get 3/4. Perpendicular have slopes that are opposite reciprocals of each other. So M1 is the opposite reciprocal of M2. So if I have 5/8, the opposite means that positive becomes negative. The reciprocal means 5/8 becomes 8/5. So these technically, I don't want to say that these are equal to each other, but if this is M1, then this should be M2 and vice versa. So the opposite reciprocal is how I get it. So let's try something. So like I did earlier, A I'm going to do, and B I'm going to leave you to do for your homework. Well, just a little extra that I'm throwing at you. Let's try the first one, letter A. To tell whether the lines are parallel, perpendicular, or neither. Neither means their slopes are neither the same nor opposite reciprocals. It's just neither. Let's try this. Find my slope. 4 minus 1, y2 minus y1 over 0 minus 1. 4 minus 1, well, that's 3. 0 minus 1 is negative 1, so this is negative 3. So let's find, this was line 1. Let's find line 2. So line 2, the slope, we have negative 3 minus 3 over 0 minus a negative 2. Negative 3 minus 3 is negative 6. 0 minus a negative 2 is 0 plus 2. So this is negative 6 over 2, which is negative 3. My slopes are equal. So my two lines are parallel. And back in geometry, we said that meant parallel. So my two lines are parallel because the slopes are equal. Letter B, I want you to try. I want you to find the two slopes. I'm getting letter B to be neither. Double check that you can come up with that same answer. Okay, so that was Chapter 2, Section 2. Let's see what else we can do. Hopefully you went and did a practice of that problem. Chapter 2, Section 4 is writing equations of lines, slope-intercept form, point-slope form, what I need to do. So writing equations of line. Given the slope m and y-intercept b, use the equation y equals mx plus b. Point slope. If I'm given the slope m and a point x1, y1, doesn't matter what the points are, use this formula. Y minus y1 equals m times x minus x1. We've talked in the past that slope-intercept form, I could do the same thing, but this turns out to be a little easier of a problem. So we're going to look and see what this looks like. 2 points, given 2 points, x1, y1, x2, y2, use the formula m equals y2 minus y1 over x2 minus x1. Change a y over change an x to find the slope. Then use the point slope form with this slope and either of the given points to write an equation of the line. So I find the slope, and then I use either point slope or slope intercept form. Let's see what we come up with. Let's try a couple of these. So here's my first example. Write an equation of the line shown. Well, here's a nice picture. Look, I have my y-intercept is the coordinate 0, 2. My slope, I'm going to go down 1, 2, 3. And right 1, 2, 3, 4. Since I went down, it's negative, so I have a slope of negative 3, 4. That's rise over run. So I know my b, like I said, was a coordinate 0, 2, so that's 2. So I have y is equal to mx plus b. So y is equal to negative 3/4 x plus 2. There's my slope-intercept form of my equation. Fairly straightforward. We've done this before. Let's look at a different example of something different. Write an equation given the slope and a point. Write an equation line that passes through 1, 2. In the past, we've talked about here's y equals mx plus b. We said to plug in the y coordinate. This is what we did in the past. You don't have to write this down. I want to talk about a new way of doing this in just a second. 1 is my x, 2 is my y. We would say y is 2, m we're told is 2, x we see over there is 1, and b, I solve for b. So I get 2 is equal to 2 plus b. Subtract 2 from both sides. 0 is equal to b. So y is equal to 2x plus 0. So y is equal to 2x. This is the old form of the way that we taught you to do things, and it works just fine. But I want to use a new form. My new form uses the point slope form that we saw on that previous slide. Y minus y1 is equal to m times x minus x1. In this problem, 1 is my x1, y is my y1. So I'm going to plug in my y1, my m, and my x and simplify. So y minus y1 is 2 is equal to my slope, which is 2, times x minus my x1, which is 1. Y minus 2 is equal to, distribute the 2, 2x minus 2, add 2, y is equal to 2x. I come up with the exact same equation. I think this is a little more straightforward. You could try either, but I do want you to be able to do this form if asked. Here is another example. Let's call this 2a. You have the coordinate 2, 3. You have a slope of negative 1/2. Can you find the equation? I'm going to give you the equation. See if you can work it out. I come up in slope-intercept form. Y equals negative 1/2 x plus 4. You can start either with point slope form or slope-intercept form. Solve for m, solve for x. Well, I have m. Solve for the equation. You might have to solve for b if you're doing this, but you do want the final equation. See if you can use point slope form. Enough talking. Next problem, pause here, see if you can do this. Write an equation of line that passes through 2, 0 and is perpendicular and parallel to the line y equals 2x minus 1. I'm going to do one of these. I'm going to do letter B, parallel first. Parallel lines have the same slope. So I want an equation that has slope of 2 and goes through the point 2, 0. I'm going to use point slope form. Y minus y1 is equal to m times x minus x1. So I plug in what I know. Y minus my y1 is 0. My m is 2. X minus my x1 is 2. So y minus 0 is y. Distribute the 2. 2 times x is 2x. 2 times negative 2 is minus 4. There's my final answer. That's parallel. What about perpendicular? Well, remember in perpendicular, I want my slope to be the negative reciprocal. My given slope is 2. Well, the reciprocal would be 1/2, and the negative of that is negative 1/2. So I want a line that goes through the point 2, 0 and has a slope of negative 1/2. So I'm going to say y minus y1 is equal to m times x minus x1. Know where I'm starting. My y1 is, my y1 is 0. My m is negative 1/2. My x is 2. Y minus 0 is y. Distribute the negative 1/2. Negative 1/2 times x is negative 1/2 x. Negative 1/2 times negative 2. Negative times a negative, positive. 1/2 times 2 is 1. There's my equation. I can find parallel lines. I can find perpendicular lines. Write an equation of the line shown. Write an equation of the line that passes through negative 2, 1 is perpendicular, is parallel. Again, this one on the left, it's best to do in slope-intercept form. Find an m, find a b, and plug it in. Do this one and see. I came up with y is equal to 2/3 x minus 1. See if you can match it. Over here, you need to find a and b. For a, for perpendicular, I got y equals negative x minus 1. For parallel, I got y is equal to x plus 3. See if you pause now and see if you can get those three answers. So, what can I do now? There's one last step I need to hit. How long has we been going? A little over 20 minutes. I'll be a couple more minutes. I want to write an equation of a line that passes through these 2 points. So first I have to find my slope. So I want change in y over change in x. So I'm going to do 3 minus a negative 2 divided by negative 1 minus 3. 3 minus a negative 2 is 3 plus 2, which is 5. Negative 1 minus 3 is negative 4, which is negative 4. So I have a slope, hold the phone. Like I said, I have a slope of negative 5/4. I'm going to plug this into point slope form. Y minus y1 is equal to m times x minus x1. Now the question you have to ask is, well, which point do I want to choose? It doesn't matter what x1 and y1 is. I'm going to choose the first one. So this is my x1, this is my y1. I just as easily could have picked this same point, this point over here. It does not matter which point I choose. It's going to give me the same equation. So it's y minus my y1 is 3. My slope is negative 5/4. X minus my x1 is negative 1. So this is y minus 3 is equal to negative 5/4 times x plus 1. Distribute the 5/4. Y minus 3 is equal to negative 5/4 x minus 5/4, because negative 5/4 times 1 is negative 5/4. I'm now going to add 3 to both sides. Y is equal to negative 5/4 x. Remember, negative 5/4 is really negative 1 and 1/4. So 3 minus 1 and 1/4 is going to be a positive 1 and 3/4. You could always use your calculator. If you do it, you could get 1.75. So y equals negative 5/4 x plus 1.75. But we like fractions, so if you can do the fractions, that's great. A mixed number would be 7/4 versus 1 and 5/4. Either way, that would work. Here is another example. If you want to try this next example, I will have the answer for it in class. And lastly, I have a question for you to ponder. I want to write the equation of a perpendicular bisector of the line segment joining -1, 4, and 5 halves. Not only do I want a perpendicular to this line, but I want its bisector. So first I have to find its slope, and then I have to find a couple other things. See what you can do with this problem. Write it down, see what you can do coming up with it, and I will talk to you tomorrow.